Okay, so we're going to talk about taking the derivative of log functions. In particular, we're going to focus on the natural log, also known as ln. How are your natural log skills from pre-calculus? They're rocking good, right? This will be easy. If they're shaky, this might be a little shaky. We're learning a new derivative technique today. Oh, hold on, let me click. There you go. Derivatives of logarithmic functions. Excellent. We're going to figure out how to take the derivative of a log equation, natural log, and even, since we're feeling fancies in our panties, we're going to take the derivatives of a log base, I don't know, 12 if you like. Log base b. Log base whatever else. Not just, wait, let me back up. You do know that the natural log is log base e, yes?
Yes.
Okay, so you did learn something last year, you liars. Let's go. Then you're going to have to remember your log properties. That might be a struggle for some of you. I have some review for you built in. It'll be okay. Now we're going to learn logarithmic differentiation. Sounds scary. Looks scary. That's why I made it orange. It's not scary. It's easy. Orange is like Halloween. I did not do it because of Halloween, because I hate Halloween. That's scary. And then we're going to talk about the three possibilities we currently covered. The first one is a variable raised to a constant. We've done that already. Taking the derivative of that is simply the power rule, 2x. If you're struggling with that, we have to talk. Number two, we talked about what happens when you have a constant raised to a variable or a function. We focused mainly on e to the x, but we also did any number raised to the x. Itself times the natural log of the base. Now, today, we got new stuff. A variable raised to a variable, or a function raised to a function. This is going to get exciting, kids. Here we go. Okay, so let's start with something very simple, and that is a quick review. I talked about these already. There they are again for you. Notice that the left one is identical to the right one. Because what's the natural log of e? 1. Correct. So if a on the right happens to be e, then it's still the same thing. Questions? Good. Find those two derivatives. I'll wait. By the way, A is considerably easier than B because B involves? No, not trig. Yes, trig, but why is B more difficult? Product rule. Oops. Sorry. Okay, now fill that in. What's dy dx? What's the derivative of that thing up on top?
So you have to differentiate the exponent first. So like it's itself
Here, stop having fun.
That's brutal.
Three So bad.
So it's
What do you mean don't look at the U? It becomes an N. Now it's From now on, when you don't hear someone, just go. All right, we good? Problems? Maybe. Let's do the easy one first. Okay? What's the derivative of e to the 2x minus 3? I don't want to hear your complaining. Give it to me.
I don't know how to do it.
Yes, you do. It's right here. What's u?
2x minus
Good. So what's e to the u? Itself times what's du dx? 2. Now this is the point where I mock you. I can't do this. You just did it. Good. Jenna, what's y prime for part B?
You would do 3 to the x cosine x
Itself times
times the natural log of 3 times cosine x plus negative sine
You missed something.
x times x. or the-
Yep, you need an x in there. So hold on, I'm just going to clean this up a little bit. So minus x times the sine of x. Does that need reviewing, or are we good? Jenna, could you explain where the cosine minus x sine x came from?
Because you have to do the product rule for x cosine x to find the derivative.
Good. Derivative of the first, derivative of x is 1 times cosine, plus the first times the derivative of the second, so it's x times the derivative of cosine, which is negative sine. Good. Problems? Excellent. Let us continue. What if we want to take the derivative of the natural log function? It's easy. Now, the difference between 1 and 2 is the idea that in 1 it's just plain old x. That's not going to happen very often, so therefore we're going to focus on number 2. And the thing that you want to pick out of all that malarkey up there is that guy right there. U prime over u. By the way, that's a comma. Pretend it's not there. Somebody who is grammatically accurate put a comma in there, so just pretend that that's not there. Not there. Okay. U prime over u. That's all you need to remember. The derivative of the function you're taking the natural log of over itself. Anything not clear about that? Beautiful. We're going to do that ad nauseum in a second, because I got to give you one more thing. What if it's not log base e, also known as the natural log? I got this little guy for you down there. However, I realized after I did this, you probably want this. Still u prime over u. You just got to remember to stick the natural log of base in the denominator. Because what's the natural log of e? 1. They are the same formula. Are we good? Julia, why are you staring at the screen squinting?
I'm just like kind of confused. Like, where did you get that? Like, where did that come from?
Where did what come from?
The thing you just wrote.
The thing I wrote? it came from the bottom one. I just replaced the x's with the u's.
Okay.
Because very seldomly are you just going to get the natural log base 7 of x. You're probably going to get the natural log, or the log base 7 of x squared minus 3x plus 4b. Okay. U prime over u, or u prime over u times the natural log b. Okay. Good? Excellent. Here we go. Lucy, you're starting. What is the derivative of the natural log of 2x? You bet I am. What's u prime? Well, let me back up. What's u? No. What's u in that problem? Good. What's u prime? What's u? 2x. So therefore, what's the derivative? Right? Also known as? 1 over x. Let's give it up for Lucy, everybody. Well done. Okay. Beautiful. Next on the agenda, Charlie. What's the derivative of the natural log of x squared plus 1?
2x over x squared plus 1.
Nice. Let's give it up for Charlie. Well done. So you're thinking to yourself, I'm just going to cancel those x's. Right? Cancel the x on the top, cancel one of the squareds. You're good to go, right? So it'd just be 2 over x plus 1? No. Bad math. Jack, I got you started on this one.
Right.
Tell me what the final answer is.
It's just 2x on of x.
Say again?
It's just 2x on of x. So
Nope.
2 sixteenths. Oh, I can't read. That's fine.
Reading is a wonderful skill.
Yeah.
Mhm. What's the derivative of the natural log of x?
1 over x.
Times x.
1 over x. So x over x, so it's 1.
1.
So it's just
Okay, what's the derivative of x?
1.
1 times the natural log. 1 times the natural log is 1.
Oh. That one.
Good. Not bad. We're going to give you a golf clap on that one because I had to coach you a little bit too much on that one.
Just a little bit. Okay.
Last but not least, Kira. Oh yeah. What's the derivative? And I got you started on this one also. What's the derivative? Oh, hold on. While she's solving that to give me an answer, let me make sure we're all on the same page. Is it safe to assume you understand the difference between these two things? Yes. What's being squared in the left one? Sorry, that's a cube. Math is a wonderful thing. What's being cubed in the left thing? X. What's being cubed in the right thing? Good. And by the way, this makes no sense. This isn't trig. Okay, don't do that. Okay, Kira, back to you. Well, I did the first part for you. Bring the exponent down, reduce it by 1. Chain on the derivative of the thing inside.
Yeah.
What's the derivative of natural log of... I almost told you the answer. What's the derivative of the natural log of x? 1 over x. Boom. No, the x's can't cancel. You got to take the natural log of something. Ben?
Would it be possible to have like 3 natural log of x squared over x?
3 times the natural log of x squared over x.
Yeah, is that
For this guy?
possible? Yeah, is that
Oh,
possible?
sure, yeah, you could write it this way.
Okay.
Good. Okay. Now notice only the first 2 involve u prime over u directly because you're taking the natural log of a mess. In C and D, you have to involve product rule and chain rule in order to get those answers. We okay so far? Anybody crying yet? Alec, you good? You're not crying? Good. Proud of you. Now is the pre-calc review. Depending on how well you learned logs last year, this may be easy peasy. It might be a little bit more difficult. Number 1 doesn't warrant discussing, even though I just did. Number 2, the log of a product is the sum of the logs. Number 3, we'll use number 3 a lot. The log of something involving an exponent, you can move the exponent out in front. And then last but not least, the log of a quotient is the difference of the logs. Okay? You got all this? Let's use it. How are we going to use it? We're going to take some derivatives. Yeehaw! We're going to take, in fact, the derivative of, it's not x to the x, it's actually x to the 2x. We'll get there in a second. Okay? Another method for taking derivatives. Now, it seems initially that logarithmic differentiation is a very niche derivative technique. It can be used in any one of the things that we've already talked about. It's just too much work. The comparison I would give you is that you learn how to factor so that you don't have to solve a quadratic using quadratic formula, because it's ugly. You could take the derivative of every single function I give you using logarithmic differentiation, but you wouldn't want to do that because it's scary when you do that. But there are certain times when you have to. And this example is when you have to. I'm going to take the derivative of x to the 2x power. A function raised to a function, we're going to use logarithmic differentiation. No?
We'll talk at 3 after school.
You bet. Okay, so 3 steps, and they're pretty straightforward. Take the natural log of both sides. Apply that stuff you learned last year in pre-calc. Solve for y prime. Okay, here we go. Ready? Yeah. Okay, so I took the natural log of both sides. Now I'm going to apply my log properties. I'm going to leave the left-hand side alone for a second and apply a log property. The log of a function with an exponent, you can bring the exponent out in front. Okay, so far? If you prefer some parentheses, we can do this. Step 2. No, I lied. Step 3. No, step 2. Hold on. Step 2, differentiate implicitly. I can do that. What's the derivative of the natural log of y?
1 over y prime.
Good. 1 over y prime, also known as y prime over y. Right? Also
Yes,
known as
that'd
u
be
prime
easy.
over u.
That'd be, yes.
So for instance, what is the derivative of the natural log of smiley face?
Smiley face prime over.
Smiley face prime over oh, that guy's got a hair lip going on there. I don't know. He's got a smirk. Okay, good.
Smirking at it.
Exactly. Erase your eyes. I'm going to leave that there just to bug some people.
Oh, stop. No. Why?
That y prime over y will always happen. It doesn't matter what you're taking the derivative of the natural log of, it's always going to be u prime over u, in this case y prime over y. You can see where this is going now. Product rule, 2 times the natural log of x plus 2x times 1 over x, which is 2 times the natural log of x plus 2. Did I lose anybody? Are we good? We're good? Okay. But notice step 3, solve for y prime. I didn't solve for y prime yet. Y prime is equal to 2 times the natural log of x plus 2. All of that times x to the 2x. Go ahead and ask.
Oh, because y is equal to.
Bingo. And where did the question you were going to ask is where did the x to the 2x come from? It's the same thing as y. I didn't know if you needed that step or not. I assumed you did not. What's the matter?
Oh,
Why is it y?
yeah.
Because of the y. I multiplied both sides by y.
Because it's y prime over y. And then this one for y prime.
To go from here to here, I multiplied both sides by y. So this should actually be y, but we know what y is. Y is the original function.
What happened to the LS?
We took the derivative of it.
I guarantee that half the kids in Southeast don't.
No, the original function is x. We go back to this one. Why did this cause everybody to go, oh? Because you forgot that y is x to the 2x. You thought y was the natural log of x to 2x. Yeah, but there's a natural log here.
Even I knew that.
All right, let's just pretend that didn't happen.
Even I knew that.
Okay, so when you have a function raised to the function, you have to use logarithmic differentiation. But, as I mentioned earlier, you can use it for functions. You can use it for functions that don't involve natural logs. So, for instance, I have this. Now you're saying to yourself, well, I could just solve that by doing a quotient rule with some chain rules involved in it. And the answer would be you are 110% correct. You're more correcter than 100%. You got the bonus question. However, I would argue that this is easier to do using logarithmic differentiation. And I'll show you what that looks like. And then you can make up your mind whether you would use quotient rule or logarithmic differentiation. Okay, we ready? Yeah. Here we go. Step 1, take the natural log of both sides. Step 2, apply your log properties. Lot just happened there.
Yeah. Oh, it's 1/2 because it's
The natural log of a quotient is the difference of the natural logs. The natural log of something raised to an exponent means you can move the exponent out in front. The square root of something is equal to raising it to the 1/2 power. Are you ready?
Just a little bit.
Would you like me to close that? Sure. Sure. Okay. The end of step 2 is take the derivative of both sides. What's the derivative of natural log of y? Oh, I'm so proud of you guys. Equals. Oh, sidebar again. Many of you, I mean a lot of you, if I give you that to take the derivative of, different example. If I give you this to take the derivative of, many of you are doing that as a product rule, which isn't wrong, it's just way too much work. Okay. In other words, you're doing the sine of x times 0 plus 2 times the cosine of x. That goes away, and you get that. Remember, the constant times a function is just the derivative times the constant. Okay. So save yourselves a lot of work. We'll leave that dot there for you. So 2 times 1 over x minus 2. Okay. U prime over u. The derivative of x minus 2 is 1. Over itself is x minus 2. Minus 1/2 times 2x over x squared plus 1. How are we doing so far? Good? Okay. Now, let's get all fancies in our pansies here. Cancel, cancel. Don't need that 1 there because you're all fairly bright. Okay, we're going to have to go to here. Y prime over y. Is that right?
X squared plus X.
All right, that's what I meant. Good.
It's just a test. Yep.
Is that right? Okay. Not done yet. Need to solve for y prime. So y prime would be equal to 2 over x minus 2 minus x over x squared plus 1. All of that times the original function, which I don't remember.
X minus 2 squared quantity.
X minus 2 quantity squared over the square root of
X squared plus 1.
x squared plus 1. Do you need to simplify that? No. However, if you did, what would it look like? Well, you would find a common denominator in this mess. Then multiply it by that mess on the right. Then simplify, cross things out, don't cross things out, do whatever you want. We're going to stop there. Okay? And to be honest, we're probably never going to simplify anything that ugly. That probably looks different than what you would get if you go back to the original problem and do the quotient rule with chain rules. But the values are the same. So some of you are getting derivatives and it doesn't match the answer key and you're freaking out. But those are equivalent statements. If you plug 17 into my answer and 17 into your answer using quotient rule, you should get the same value. Okay? Questions? Don't need to use logarithmic differentiation. Need to use logarithmic differentiation. Okay? I realized last period I used this one already, didn't I? Yeah, sorry. I'll try to be better. Let me stop this, and then we'll talk about the schedule because we have some changes.